At 17 hours and 13 minutes, universal time tonight, an eighth earthquake above magnitude 4.5 hit the seafloor off the coast of Russia on a segment the Japan Meteorological Agency has been officially warning about since last summer. The cluster is still adding events, and on the other side of the Pacific Ocean, the California cluster from yesterday is also still active. Two opposite corners of the same plate, both shaking inside the same 48 hours, both on segments already under official watch. In the next 20 minutes, you'll know exactly what's happening, why it matters, and what every seismologist watching tonight is bracing for. At 17 hours and 13 minutes universal time tonight, the GFC German Research Center for Geosciences reported a magnitude 5.1 earthquake off the southeastern coast of the Kamchatka Peninsula in the Russian Far East. The epicenter sat at 51.88 degrees north latitude, 159.18 degrees east longitude, depth 10 kilometers. It was the eighth confirmed magnitude, 4.5 and above earthquake, to hit the same small box of ocean in the past 36 hours. And it was the most recent event in a cluster that, as of this recording, is still actively adding earthquakes. That cluster is the story tonight. It is sitting on one of the most violent and best monitored subduction zones on the planet. It is sitting on a segment of that subduction zone that is already under an active megaquake advisory from the Japan Meteorological Agency. In effect, since last summer's magnitude 8.8 rupture left an unbroken neighbor segment loaded. And it is sitting, as of tonight, on the exact patch of fault that Japan's National Seismic Authority has been watching for almost a year, waiting to see exactly the kind of thing that started happening yesterday. Yesterday's video covered the cluster that hit off the coast of Northern California and Southern Oregon at the Mendocino Triple Junction. That cluster is still active tonight. The magnitude 5.7 off Pistol River, the magnitude 5.1 off Petrolia. The additional magnitude 4.5 and 4.6 events that came through the evening of June 3rd Pacific time and into the morning of June 4th, they are all part of the same 48-hour window. While that California cluster has been holding America's attention, this second cluster has been building on the opposite corner of the same plate. Two corners, two clusters, both still developing. That is the framing every seismologist watching the global catalog tonight is sitting with. Here is what the data shows on the Russian side. The Kamchatka cluster is concentrated in a roughly 50-kilometer box of ocean, centered on approximately 51.5 degrees north latitude, 159.5 degrees east longitude. That puts it about 150 to 200 kilometers south-southeast of the city of Vilyuchinsk, which sits on Avacha Bay near the southern tip of the Kamchatka Peninsula. Vilyuchinsk is the base of the Russian Pacific Fleet's submarine forces. The adjacent regional capital, Petropavlovsk-Kamchatsky, holds the bulk of the peninsula's roughly 300,000 residents. The cluster is happening offshore from both of those cities. The cataloged events, working backwards from tonight, the magnitude 5.1 at 1713 Universal Time on June 4th at 51.88 north, 159.18 east, depth 10 kilometers. Reported by GFC. The magnitude 4.6 at 02 hours, 32 minutes Universal Time on June 4th, depth 20 kilometers. Reported by the Russian Academy of Sciences Geophysical Service. The magnitude 4.5 at 04 hours, 34 minutes Universal Time on June 4th. Depth 45 kilometers. Also from the Russian Academy. The magnitude 5.2 at 17 hours, 23 minutes Universal Time. On June 3rd, this is the largest event in the cluster so far, cataloged by both the European Mediterranean Seismological Center and the United States Geological Survey under event identifier US 7000 SQCW, listed as 188 kilometers south-southeast of Vilyuchinsk, depth 10 kilometers. Within 45 minutes of the largest event, the European Mediterranean Seismological Center logged a magnitude 4.7 at depth 20 kilometers. The Russian Academy of Sciences added two more magnitude 4.6 events through the night of June 3rd at depths of 40 kilometers. The European Mediterranean Seismological Center added a magnitude 4.5 at depth 32 kilometers. The United States Geological Survey added another magnitude, 4.5 at depth, 35 kilometers under event identifier US 7000 SQEC, added up. 8 to 9 confirmed magnitude 4.5 and above, earthquakes inside 36 hours, in a box less than 50 kilometers across. That is not the activity rate of a normally behaving piece of seafloor. That is the activity rate of a fault system that is doing something. The depth distribution matters here. The shallowest event is at 10 kilometers. The deepest is at 45 kilometers. The events in between span 20, 25, 32, 35, and 40 kilometers. That range covers the full vertical extent of the megathrust interface between the Pacific Plate and the Okhotsk microplate, plus the upper portion of the subducting Pacific slab itself. A single fault patch firing repeatedly produces aftershocks within a narrow depth range. A cluster that activates the interface at multiple depths across 35 kilometers of vertical extent is more consistent with a broader regional stress increment, activating multiple discrete fault patches. The other thing the cluster is not doing is tapering. Standard aftershock decay under Omori's law, the basic statistical model that has described aftershock sequences worldwide for 130 years, predicts that aftershock rate drops as the inverse of the time. Since the largest event in this cluster was the magnitude 5.2 at 1723 Universal Time on June 3rd. 24 hours later, the cluster produced the magnitude 5.1 at 1713 Universal Time on June 4th. Almost identical magnitude to the largest event, almost exactly 24 hours later. That is the opposite of Omori decay. That is a cluster sustaining its event rate, not tapering it. And that signature is consistent with either multiple discrete fault patches firing on a regional stress increment or a sustained ongoing stress source. Both readings raise the conditional probability that this cluster is not yet at its largest event. The Kuril-Kamchatka Trench is one of the longest and most active subduction zones on Earth. The trench runs offshore parallel to the Kamchatka coast and extends approximately 10,000 kilometers in total, from northern Hokkaido in northern Japan up through the Kuril Islands, along the eastern margin of Kamchatka, and around the Komandorsky Islands toward the Aleutian Trench. The Pacific Plate is being subducted beneath the Okhotsk microplate along that boundary at approximately 7 to 9 centimeters per year, among the fastest subduction rates on the planet. By comparison, the Cascadia margin off the coast of the Pacific Northwest is converging at about 2.5 to 3 centimeters per year. The Kuril-Kamchatka rate is roughly 3 times faster. What that fast convergence rate means in practical terms is that the locked patches on the interface, the patches where the two plates are stuck together, accumulating elastic strain, fill up with strain on relatively short timescales. The recurrence intervals for magnitude 8 and above earthquakes on individual segments of the Kuril-Kamchatka arc are typically in the range of 70 to 150 years per segment. The historical record of large events on this arc is dense. There were major magnitude 8 and above earthquakes at 1737, 1841, 1923, 1952, 1959, 1963, 1969, 1997, 2006, 2007, and 2024. The 1952 Severokurilsk earthquake is the historical anchor for this arc. It was a magnitude 9.0 event, the 5th largest earthquake ever recorded by modern instruments. The rupture extended over approximately 600 kilometers of the southern Kuril-Kamchatka system. The seafloor displacement generated a trans-Pacific tsunami that reached Hawaii with wave heights of about 12 feet and was recorded on the coasts of South America, and an estimated 2,336 people died. Most of them in the small Russian town of Severokurilsk itself, which was inundated by waves up to 50 feet high within 15 minutes of the earthquake. The Soviet government did not publicly acknowledge the disaster for decades. The number we have today is the figure derived from post-Soviet archive research, and the real number may be higher. That same general region is the region where the most recent magnitude 8 and above earthquake on this arc struck in late July of last year, 2024. The 2024 Kamchatka earthquake registered at approximately magnitude 8.8, the second largest earthquake on Earth in the past 15 years, behind only the 2011 Tohoku event in northern Japan. And what that 2024 rupture did, or more importantly, did not do, is the reason tonight's cluster matters institutionally. The 2024 magnitude 8.8 ruptured a substantial portion of the southern Kuril-Kamchatka segment. The rupture extended several hundred kilometers, displaced the seafloor by tens of meters across the rupture surface, generated a trans-Pacific tsunami that was recorded at tide gauges on the Hawaiian, Alaskan, and South American coasts. The detailed source studies in the months after the event mapped the slip distribution across the rupture surface and found something important. The slip concentrated in the central portion of the rupture, tapered to lower displacement at the edges, and at the northern end of the rupture, the slip distribution tapered to essentially zero at a structural barrier somewhere short of the full geometrically capable length of the loaded segment. That means the 2024 rupture left a piece of fault behind. The piece of fault that did not rupture in 2024, the unbroken neighbor to what did rupture, sits immediately to the north of the 2024 rupture's northern terminus. It was loaded by the same long-term tectonic process that loaded the rupture itself, but it did not release its accumulated strain. When the 2024 event unloaded the patch that did rupture, it redistributed Coulomb stress onto its unbroken neighbor. Published source studies in the months after the event estimated that stress increment at approximately 1 to 10 bars, small in absolute terms, but large in relative terms, for advancing the failure clock on the receiving segment. The standard reference framework for this kind of stress triggering is King, Stein, and Lin 1994 in the Bulletin of the Seismological Society of America, which documented numerous historical cases where stress increments in that range have measurably advanced the timing of subsequent failures on adjacent segments. The Japan Meteorological Agency reached the same conclusion in its post-event analysis. In the months following the 2024 magnitude 8.8, the agency issued a megaquake advisory on the southern Kuril-Kamchatka and northern Japan Trench segment. The advisory is institutional acknowledgement that the unbroken neighbor segment is loaded, that the loading has been advanced by the stress redistribution from the 2024 rupture, and that elevated public preparedness is warranted. The agency was explicit in its public communication that the advisory is not a prediction of any specific magnitude or any specific timeline. It is a flag, an institutional statement that the loading state warrants elevated monitoring and elevated public preparedness messaging. That advisory has not been lifted as of this recording. The unbroken neighbor segment is still officially being watched, and the cluster that has been building over the past 36 hours is sitting on it. That is what makes the cluster matter institutionally. It is not just dense. It is not just sustained. It is not just spanning the full interface depth range. It is doing all of those things on the exact piece of fault that Japan's National Seismic Authority has been officially watching for almost a year, with an active advisory in place, waiting for exactly this kind of pattern to develop. The cluster is the kind of pattern the agency designed the advisory to flag. Now look at what is happening on the opposite corner of the same plate at the same moment. The cluster off the coast of Northern California and Southern Oregon is still active. The magnitude 5.7 at 138 kilometers west-southwest of Pistol River, Oregon at 10 hours, 53 minutes universal time on June 3rd, the magnitude 5.1 off Petrolia. The additional magnitude 4.5 and 4.6 events through the evening of June 3rd Pacific time. The cluster, like the Kamchatka cluster, is not tapering. The southern Cascadia margin has been loaded by approximately 2,694 cataloged tremor events in the past 30 days, on the deeper interface, concentrated beneath the locked southern segment from Northern California through Southern Oregon. The interval since the last full margin Cascadia rupture in January of 1700 is 326 years and 4 months past 100% of the most recent 4,000-year paleoseismic record, where the longest documented inter-event interval was 291 years. 2 clusters, 2 segments, both still developing. Both on segments, their respective national seismic authorities are already officially flagging. approximately 7,500 kilometers of open Pacific Ocean between them. And between them, holding them apart and holding them together, sits the Pacific Plate. The Pacific Plate is the largest tectonic plate on Earth at approximately 103 million square kilometers, covering roughly 20% of the surface of the planet. It moves as a single coherent rigid body at approximately 7 to 10 centimeters per year in a west-northwest direction. It is driven primarily by slab pull at its western subducting margins, Japan, the Kurils, Kamchatka, Tonga, Mariana, and by ridge push at the East Pacific Rise on its eastern edge. Mechanically, the plate is one object. Its two opposite locked corners are connected through the rigid body between them. What that means physically is something the literature is careful about. The two corners are mechanically connected, but the stress amplitudes that propagate from one corner to the other at distances of 7 to 8,000 kilometers are small. From a major earthquake at one margin, the surface waves arriving at the opposite margin carry transient stress amplitudes of approximately 1 to 10 kilopascals. The local tectonic stresses that drive earthquakes are on the order of 1 to 10 megapascals, 3 to 4 orders of magnitude larger. The connection is real. The amplitudes are small. The literature on what the field calls remote dynamic triggering has documented detectable triggered seismicity at hemispheric distances for 30 years. The foundational paper is Hill and colleagues in 1993 in the journal Science, documenting triggered clusters across the western United States. In the hours and days after the 1992 Landers earthquake at magnitude 7.3, the subsequent literature expanded the framework. Velasco and colleagues in 2008 in Nature Geoscience documented global triggering effects from the 2004 Sumatra Andaman earthquake at magnitude 9.1. Politz and colleagues in 2012 in Nature documented Coulomb stress transfer effects from the 2012 East Indian Ocean earthquake at magnitude 8.6. Brodsky and Prejin in 2005 in the Journal of Geophysical Research established the lower bound triggering effects at hemispheric distances require source events of approximately magnitude 7.5 or larger. That threshold matters for tonight. Both present clusters have produced events in the magnitude 5.1 to magnitude 5.7 range. They are an order of magnitude below the threshold the literature treats as the lower bound for hemispheric triggering effects. At the present magnitudes, the literature does not support a claim that the two clusters are triggering each other across the Pacific. They cannot be at these magnitudes. The surface wave amplitudes from a magnitude 5.7 source 7,500 kilometers away are several orders of magnitude below the threshold at which any documented case of remote triggering has ever been observed. What would change that picture is escalation. If either cluster produces a magnitude 7 or larger event in the coming days, the picture changes. A magnitude 7.5 or above on either side would clearly cross the threshold and make remote dynamic triggering of the opposite corner a literature-supported concern. At the present magnitudes, the two clusters are independent expressions of two independently primed local loading clocks that have arrived at firing window states at the same calendar moment. That alignment, on its own, is statistically unusual but not unprecedented. Historical catalog analyses put the rate of comparable simultaneous co-occurrences on opposite Pacific corners at approximately 1 to 3 times per year globally. There is another claim circulating in the online conversation around tonight's events that deserves a brief debunk. The X-class solar flare on June 3rd, the multi-CME passage now in transit, the G3 geomagnetic storm watch valid for tonight and tomorrow, none of that is triggering the earthquake clusters. A major geomagnetic storm couples approximately 10 to the 10th or 10 to the 11th joules of energy to Earth's crust at the upper bound. A magnitude 5.7 earthquake releases approximately 6 times 10 to the 13th joules of strain energy. The earthquake released 600 times more energy than the storm delivered to the crust. The arithmetic forecloses the claim. The literature, including Marcatelli and colleagues in 2020 in Scientific Reports, documents a small temporal modulation effect of solar activity on global seismicity at the multi-decadal scale, but the effect, if causal, operates as a small temporal nudge on earthquakes that were already loaded to failure, not as a generator of seismicity. The strong causal version of the claim does not survive the arithmetic. The watch window over which this question resolves is days to weeks. The single observation that would most decisively shift the reading is an escalation on either side. A magnitude 6 or larger event on the Kamchatka cluster, or on the California cluster, would tighten the foreshock interpretation for that segment substantially. A magnitude 7 or larger would essentially confirm it, would raise the conditional probability of a still larger rupture on that segment, and would make remote dynamic triggering of the opposite margin a real literature-supported concern under the Hill, Velasco, Paulitz, and Brodsky framework. Under the Gutenberg-Richter magnitude-frequency relation, the basic statistical relationship that for every one earthquake of a given magnitude on a fault system, you expect about 10 earthquakes 1 magnitude smaller. The conditional probability of either cluster eventually producing a magnitude 6 event somewhere in its evolution is in the range of 15 to 25%. The corresponding conditional probability of a magnitude 7 on either cluster is in the range of 2 to 4%. These are conditional baselines, not predictions, but they tell you what the standard statistics expect, given what the clusters have already produced. The institutional postures of both national seismic authorities are tightened. The Japan Meteorological Agency continues to maintain the megaquake advisory on the southern Kuril-Kamchatka segment. The United States Geological Survey is monitoring the Mendocino Triple Junction and Southern Cascadia interface in real time. Neither agency is going to issue a stronger warning unless escalation forces it, because strong short-term earthquake prediction is not within the technical capabilities of any agency anywhere in the world. The lesson of the 1975 Haicheng evacuation success in China and the 1976 Tangshan failure the year after Haicheng evacuated successfully before a magnitude 7.3 earthquake, Tangshan struck without warning and killed approximately 240,000 people, is that even when precursor signals exist, they are rarely distinguishable in real time from background fluctuations. The agencies will monitor. They will tighten or loosen the postures depending on what the catalog adds in the coming days. What we will know in the coming days, and what the catalog will tell us, is whether tonight's pattern is the leading edge of something larger that the catalog has not yet seen, or whether it is one of those 1 to 3 times per year cases where 2 independently primed segments produce coincident catalog visibility on a 48-hour clock and nothing more. The literature cannot determine that question in advance. The data will determine it as it comes in. Until then, 2 corners, 2 clusters, both still developing, both on segments their respective national authorities are already officially watching. And the window over which the picture comes into focus is, by every relevant agency's own framing, days to weeks. We will be tracking this as it develops.